In this video, we're going to do a bunch of practice problems related to the chain rule. So we're going to find these following derivatives. First one, the derivative of square root of x plus 1. And it's important to note that all the problems that we do today are not just going to be straightforward applications of the power rule or exponential functions or product or quotient rule. They're all going to require the chain rule. So square root of x plus 1, first step I need to do is identify the inside and outside functions. Here, the inside function is going to be x plus 1, and it is inside of the function square root of something. Or you can write that as square root of u, where u is equal to x plus 1, or square root of x, where x is equal to x plus 1. Once we've done that, we need to take the derivative of the outside. And that's going to be, note this is the same thing as x to the 1/2 power. That's going to be 1/2 something to the negative 1/2. Or I'll write that maybe as 1/2 x to the negative 1/2. Step 3 is I need to leave the inside function alone. So I'm going to write this as 1/2 x plus 1 to the negative 1/2. Then step 4, I need to find the derivative of the inside. So I'm going to write my final answer now as, or almost final answer, 1/2 x plus 1 to the negative 1/2 times the derivative of x plus 1. This derivative tells me I have something else to do. I have to take that derivative, and it will be equal to 1/2 x plus 1 to the negative 1/2 times that derivative is just 1. This is 1/2 x plus 1 to the negative 1/2, which you could write as 1 over 2 square root of x plus 1. All right, let's do it 7 more times. The derivative of e to the 3x, step 1, identify the inside and outside functions. Here we have 3x is inside of e to the something, or e to the x. We're going to take the derivative of the outside function, and that's just going to be e to the something, or e to the x. That's the nicest derivative that we have. It's the same function back. Step 3, we're going to leave the inside function alone, so that's going to be e to the 3x power, and then bring it all together with the fourth one, and that's going to be our answer, which is e to the 3x power times the derivative of 3x. And put it all together, this is going to be e to the 3x times 3, or 3e to the 3x. Now, after you have a bunch of practice problems, this will be a very simple kind of derivative. We might even think about it as a straightforward kind of thing, just knowing we have to multiply by 3 on the outside. But this is the steps we do to kind of get to that point. Sure, I'm boxing my answer here. All right, so let's do it again. And as we go through this video, I'm going to kind of go a little bit quicker through the problems, and I'll kind of show how I would go about it if I was doing it on my own, because I wouldn't write out each step each time, but just to kind of show how we're doing it. Right now, we're still going to kind of do this, writing out the steps each time, and then as we get forward more, we'll do a little bit less of it. All right, 2 to the x cubed minus x. Here we have x cubed minus x is inside of 2 to the something, or 2 to the x power. So here I'm not going to write out step 2, 3, 4, but here I'm going to do the derivative of 2 to the x is natural log of 2 times 2 to the x. So here I'm going to have natural log of 2 times 2 to the something, and that something is going to be leaving the inside function alone, x cubed minus x. So I'm combining the second and third steps there. This is steps 2 and 3. So then my answer here is going to be natural log of 2 times 2 to the x cubed minus x times the derivative of x cubed minus x, which will give total natural log of 2 times 2 to the x cubed minus x times that derivative, which is 3x squared minus 1. And that is our answer. All right, again, here the inside function is 3x squared minus 5x, and the outside function is cubed root of something, or cube root of x. And we know that the derivative of the cubed root of x, which is x to the 1/3, is 1/3 x to the negative 2/3 power. Bring the power down out in front, decrease the power by 1. So our answer here is going to be doing the derivative of the outside function, leaving the inside function alone, and then multiplying by the derivative of the inside function. Since I have this derivative here, I have to take care of it. So our final answer will be 1/3 3x squared minus 5x times that derivative, which is 6x minus 5, 2 applications of the power rule. And that's more like how I would write this problem on my own. I wouldn't write all the steps out. I'd be kind of careful that I'm doing each step separately. All right, let's move on. Here we have 1 plus x squared plus x plus 5 cubed. And note that for this derivative, we don't need to do the chain rule at the beginning necessarily. You could write this as the derivative of 1 plus the derivative of x squared plus the derivative of x plus 5 cubed. And these first two derivatives are straightforward. This is going to be 0 plus 2x. And then we just need to figure out that last derivative. So it's important to kind of break up the problem into easier steps. Now I just have this kind of last thing to do. And note that there's actually two ways that you could do this. First way we're going to do is just using the chain rule like we've been doing. That is, the inside function is x plus 5, outside function is x cubed or something cubed, and we do the derivative of the outside function, 3 times something squared, leave the inside function alone, and you multiply by the derivative of the inside function, which is just 1. This is going to be 3 times x plus 5 squared. We can put that as our answer there. The other way to take care of that x plus 5 cubed is just to expand out that x plus 5 cubed. And if you know what that is very quickly, maybe that's a nice way of doing that. That's going to be x cubed plus 5x squared plus, sorry, not 5x squared. It should be 15x squared plus 75x plus 125. So if you know that quickly, then that might be a nice way to go about this, but that's not necessarily an easy thing to do. And the chain rule kind of works. And if this power were bigger than 3, then that would be even harder to do. So you could take care of each of those terms individually. We don't have to do the chain rule, but it's a little bit tougher overall. Note that our final answer here is 2x plus 3 times x plus 5 squared. All right, next one, we have 1 over x squared minus x4, x to the fourth. We could use quotient rule, but we're going to use the chain rule here. So again, you could use quotient rule, the top being 1, the bottom being x squared minus x to the fourth, but the chain rule would actually be easier, I think, in this case. Here, the inside function is going to be x squared minus x to the fourth, and it is inside of 1 over something, or 1 over x, which is x to the negative first power. So if I have this, then the derivative of x to the negative 1 is going to be negative x to the negative 2. And that's what I'm going to use for the chain rule. I'm going to have the derivative of the outside, negative something to the negative 2, leave the inside function alone, times the derivative of the inside. And all written out, this will be negative x squared minus x to the fourth to the negative second power times 2x minus 4x cubed. You could do this by quotient rule, but I think it's a lot less work to use the chain rule. And this is why maybe it's important to be comfortable with the chain rule outside of just the times that we need to use it. It makes some problems easier to do once we get comfortable with it. All right, a few more. So the next one is the derivative of the square root of 5 to the negative 2x minus x. And we're actually going to have two applications of the chain rule here, but we're going to be careful of doing one in front of the other. So as a whole, we have function composition here, and that is going to be the inside function is the entire 5 to the negative 2x minus x, and it is inside of square root of something, or square root of x. And we know that the derivative of square root of x, which is the derivative of x to the 1/2 power, is 1/2 x to the negative 1/2. So this is going to be 1/2 something to the negative 1/2 power. The something is the inside function, 5 to the negative 2x minus x, times the derivative, 5 to the negative 2x minus x. And note that we need the chain rule to take care of that 5 to the negative 2x. So we're going to have to do chain rule again. That chain rule is going to be the inside function is negative 2x. The outside function is 5 to the something, or 5 to the x. And we know the derivative of 5 to the x is natural log of 5 5 to the x. So, writing everything out, we have what we had from before, just keeps on coming along for the ride. 1/2 5 to the negative 2x minus x to the negative 1/2 power. And then times the derivative of 5 to the negative 2x, which is going to be natural log of 5 times 5, not to the x, but to the negative 2x, leaving the inside function alone, times the derivative of the inside function, negative 2x. And then let's not forget we have to do the minus x part, minus the derivative of x, which is minus 1. So going step by step, now we have one more derivative to do, the derivative of negative 2x. And we'll write down our final answer, 1/2 5 to the negative 2x minus x to the negative 1/2 power times natural log of 5 times 5 to the negative 2x times negative 2 all minus 1. And there's our answer. We're not going to simplify that as it gets kind of gross the more we try to do that. One more problem here, and that is an application where the chain rule is not the first thing that we should do. So as a whole, we have a function times another function. And we're going to need to use the product rule here. And this is kind of the most important question we can ask is, as a whole, are we multiplying two things together, dividing, or do we have function composition? We're going to ask that question for each derivative moving forward. So the product rule states that we should do the derivative of the first, the derivative of 0.2x, times the second, plus the first, times the derivative of the second, and we can see that in the second derivative here, we need to do the chain rule. We have the inside function is 0.34x, and the outside function is e to the something, or e to the x. So the derivative of 0.2x is going to be 0.2. It's a line, and the slope of the line is the derivative, times e to the 0.34x plus 0.2x times, now we're doing the chain rule, we're going to have e to the 0.34x times the derivative of 0.34x. We have one more derivative to do, and we can write our final answer. (0.2) e to the 0.34x plus 0.2x e to the 0.34x times 0.34. And there's our final answer. So going back through this takes a long time to kind of write out each step formally. As you get better and better, you can start skipping steps that you may already know the answer, but you do run the risk of having more mistakes, and this does catch the mistakes pretty well.